Hello, I'm Sony from the OSU Math Congregation Discord, and today I'm going to explain the solution for the problem of the day from January 13th, 2020. So, in this question, we're given that a equals the summation from k equals 8 to 1023 of log base 2 of k over k plus 1. Rewrite the expression 2 times cis a pi over 14 in the form of a plus bi. So let's start with where it tells us to start. And let's find a, because we can't solve without finding a, so we obviously have to find a first. So I'm looking at the summation here, and I see we have a log base of 2. So if this is going to come out neat, we're going to want powers of 2 in this log. Now I'm noticing I have a k8 over here, which is 2 to the power of 3. And I'm looking at this, and I realize when I add logs, I'm simply multiplying the insides. So without going too off topic, let's just see what happens when we write out the summation for a little bit. Let's just experiment. So our first term, let's just ignore the logs. Let's focus on what's on the inside. We're going to have 8 over 9. Now when you add logs, you're multiplying the insides. So times, okay, next, I'm at 9 now, so 9 over 10. And now let's try out 10. Let's see what we get. 10 over 11. And it's just going to keep going. Let's try our last term here. 1023 over 1024. Wait a minute. I think I'm starting to see a pattern here. You can cancel out this 9 and this 9 because they will just multiply to 1. You can cancel out this 10, and so forth, because all of these numbers repeat except the least and the greatest number. Okay, so after doing this summation, we're just left with this single 8 and the single 1024. So this turns into log 2, 8 over 1024. Now, I'm seeing these are just powers of 2. So let's convert this fraction into powers of 2. So now we have 2 to the power of 3 over 2 to the power of 10. Now, I know when I'm dividing exponents with the same base that you're just subtracting, sorry. So 3 minus 10 gives us negative 7. So now we're just left with log 2 to negative 7. So we have found the value for a, negative 7. Now that's one half of the problem done. So let me see if I can erase this here. Let's see. Where's the shapes at? Shapes, rectangle. Okay. Now, let's go tackle, where's the paintbrush? Let's tackle the next part of this problem. We have to rewrite the expression 2 times cis a pi over 14 in the form of a plus bi. So at first that 14 looks really weird, right? Like pi over 14, I don't think I can do half angle formula to find that. But when we plug in our a, it actually turns out quite nice, because it's just negative 7 pi over 14, which is just going to simplify to negative pi over 2. So this is negative pi over 2. Now, I know cis is just cosine plus I sine according to Euler's formula. So we can rewrite the cis function as cosine negative pi over 2 plus I sine negative pi over 2. Now, let's look back to our unit circle. Cosine of negative pi over 2, that's going to give us 0, because that will be at 270 degrees. Then sine at negative pi over 2 is going to give us negative 1. So now we have negative I. So this is irrelevant at this point. Now we're just left with negative I. Now, all that we have to do is multiply it by 2, which gives us the answer of negative 2i. It asks us to give it in the form of a plus bi, but in this situation, a would be 0. So you can either just say negative 2i or 0 minus 2i. Fairly simple problem if you know how to solve a telescoping series of logarithms, and if you know what this formula is